We built this chatbot using a NestJS backend, integrated GPT-4 for conversational intelligence, and also used Redis for storing the conversational context. We also explored how to use open source models like Llama 3.2 and self-host them, but we had to run the backend separately, install Redis, and manage a couple of environment files. So in this video, I'm going to show you how you can simplify the deployment using Docker Compose by bundling everything required to run the chatbot and then deploy the full stack to a VPS. The knowledge that you're going to gain from this tutorial is not only applicable to this application, it's something that you can use in your own applications where you require many services for your application to work. So let's get started. Let's start with why Docker Compose helps. Deploying applications often means juggling multiple services, databases, APIs, frontends, each with its own setup. Manually managing these across environments is time-consuming and error-prone. Docker Compose solves this by bundling everything that your application requires, the services, the dependencies, in one config file, which reduces setup time. Because with just saying Docker Compose up, your system will be up and running with all its dependencies. Now that we've covered the why, let's start building. And I'm going to assume that you have Docker installed, but if you don't, I've included a link in the description which shows how to install Docker for your platform. The source code for this WhatsApp AI chatbot is available on a public GitHub repository. So if you're new, you can just do a git clone, then the link to the repo, which I've included in the description box. We are going to work in a new branch rather than doing our changes in the main branch. For that, let's use git checkout -b and dev, just say Dockerize application. Now that we are in our branch, we are going to use the docker init command to set up the boilerplate code that enables us to Dockerize our application. And you'll see that it will do most of the heavy lifting. So let's say docker init, and it has automatically detected that this is a Node.js application. I'm going to press enter on Node. We picked the version that we're going to use. It has also automatically detected that I'm using npm. Our build output for a NestJS application is dist. Press enter. What command do you want to start the app? We want to run the start prod script. And the application listens on port 3000. Docker init has created a docker ignore file, a docker file, and a compose, and a readme with instructions on how we can start the application. This is our docker ignore file, our compose file, and the docker file. The image that's being used here is the Alpine version, which is the lean version of the container, which is more secure, and you only have what you need to run the application. Open the compose file. What's going to happen is when building the application, which is the server, the compose file is going to take the instructions from our Docker file. That's why it's taking the context from the current directory. And since we are in the root path of our project, it's going to take instructions from the Docker file here for this server. We use Redis for conversational intelligence. Let us also specify Redis as a service for our application image. Let us use Redis 8, the Alpine version. And with that alone, we now have our Redis available. Our application won't be able to start without Redis, since it's a critical part of the application. To demonstrate that, let us go to the terminal. So we're going to say docker compose up. This creates all our services and creates the network and all the dependencies. Then we want to also build the application since it's our first time running it. Press enter. The application didn't start because of missing environment variables. And how do we specify the environment variables in our compose file? Let us go to our compose file, and on our server, which is the NestJS server, we specify the environment file. With this, we can add environment files to the container. Go back to our terminal, run again. Now the environment files are all good, but we can't connect to Redis. Since the Redis container and the server are part of the same Docker network, what we just need to do is, previously we're pointing to our Redis URL in our environment file using Redis URL here. We will go back to our compose file, Redis URL, and here's where the magic happens. We can reference our Redis container directly, which is this container, and the port, which is 6379. Go back to our terminal, rerun our command. Our application is started successfully, and we can even improve the configuration so that we make sure that the server, which is the NestJS application, can only be started after our Redis container is ready. To do that, we use depends on, and we specify the container, which is Redis, and the condition is service started. So we're just telling Compose, say the only way we can build and start the server is only after the Redis container has started. If we go to localhost 3000, you can see that it says hello world, signifying that everything is running as expected. Our application is working, but when we stop these containers, Redis is going to lose all the information. So the conversational context is going to be lost after that. To solve for that, we're going to make the Redis data persistent by specifying a volume on our Redis container. Let's say volumes, Redis data. What we just did here is we created a Docker managed volume for our Redis data to make our data persistent. So the information that is in the Redis container is going to be saved in the Redis data volume, which is on the host machine. So the next step is I'm going to show you how you can then take this configuration and host it on a VPS using Dokploy. This video is a continuation of the previous video in which we set up Dokploy on a VPS from scratch and deployed our WhatsApp application. Let me go to my Dokploy. This is our chatbot. We had the backend, which is the NestJS backend, and the Redis database. We created this manually, but with this new configuration, since we defined everything in the Docker Compose file, we no longer have to do that. Before doing anything else, we're going to create a separate Docker Compose file for Dokploy because there are extra steps that we have to do for us to be able to use a Docker Compose file on a Dokploy setup. Here are the steps that we need to follow. We have to add the network, add the traffic labels so that we route domains to our services. Use the copy command to copy the contents of our compose.dokploy.yaml, because we just want to extend our current compose file so that we can add what we need for a Dokploy deployment. Our Dokploy has been created here. Let us go back to the Dokploy page, copy the networks, go to our Docker Compose file, specify the network for the server, which is the NestJS application. We do the same for our Redis Dokploy network, external. What we're doing here is adding our services as part of the Dokploy network such that Dokploy would be able to deploy the application. Check the labels, paste, replace the front end app with the name of our service. Replace with server. Replace all. Entry points enables our service to be accessible via HTTP. Host is the domain that the application is running, and instead of having this be hard-coded, I'm going to make a use of an environment variable here, call it Traefik host. Take note of this because we have to later on define it on our Dokploy panel under environment. Let us also copy this part that was left out and put it under labels, and we're going to remove the front end app server. To make this less confusing, since we have server here, let us change our service name to NestJS backend. Copy this and replace instances where we're defining our service so that it becomes less confusing, since we also have server here. So this is just specifying the port on which our application is running on. Take note that we are not going to put the labels under the Redis image because the Redis image is only there to be used by our NestJS application. But what we are actually exposing externally is the NestJS application, because this is where the WhatsApp messages are being sent. So that's the only service that needs to be accessible via HTTP. And instead of specifying ports here, we just want to expose port 3000. What this does is it exposes port 3000 inside the Docker network. It's not the same as exposing the port externally. What's going to happen is Traefik is going to receive the requests and then forward that request to port 3000. Let me just commit Dockerize application, because we are going to use our GitHub branch to deploy the application using the compose file. Commit and push. On the Dokploy panel, instead of this configuration where we had the backend and Redis created separately, I'm just going to create a new service that's going to replace the backend and Redis using Docker Compose. Click on Compose. WhatsApp AI Chatbot. We're going to use a compose file. Then create. I also authorized Git deployments in the previous video. So select the GitHub account and our repository, which is Artista WhatsApp Chatbot. Then our branch, we're going to use the dev Dockerize application. We specify our Docker Compose file. In our case, it's this file, compose.dokploy.yaml file, the one we made those additional changes to suit a Dokploy deployment. And the trigger type enables us to automatically deploy the application every time that we push to this branch. Click Save. Before doing anything, we also need to specify the environment variables. We are going to go to our previous backend and copy the environment variables that are there, paste them in our new deployment that's using the simplified compose. We no longer need this Redis URL because we are using the Redis container that's part of the compose file. Click on Save. I hope you didn't forget this one. In our code, we're defining the host, which is the domain that the application is going to be running on using an environment file. So we also need to specify the Traefik host. So it's going to be Traefik host artista.ushinde.com. Then we click Save. One more change that we need to do. Instead of HTTP, we want to use the HTTPS version, which is the secure version. On the entry point, instead of just saying web, which is port 80, let us use web secure. Commit and push our code. Let us stop this deployment for a bit. I'm going to delete the NestJS backend and also delete our old Redis. When we committed our code, you could see the trigger type in action, because the moment that I committed the code, then the deployment started on its own. We click deploy. If we go to logs, you can see that our Nest application is started. The same applies for our Redis instance. So the last step, let us just add the domain, and the service name that we're targeting here, like I said before, is the NestJS backend. Then artista.ushinde, specify the container port, which is port 3000. We specified web secure. We want to use HTTPS. Let us issue an SSL certificate. We're using Let's Encrypt. Then we create. Moment of truth. I'm going to open the chatbot so that we can test and see if everything is working as expected. Hello there. It has responded. How are you today? The bot has responded. Let us also test the text to image generation. We're using the imagine trigger command. Imagine dark in a tree. And from the logs, it's showing success, but for some reason the image is not being sent. This is due to permissions. If we go back to our Docker file, you will see that we are running the application as a non-root user. We are using this user node. So what's happening is the image is being created, but saving the image is failing because the node user that doesn't have write permissions. What we're going to do is we want to give the node user write permissions within the application. Commit and push our code. As you can see, it's running using our latest commit. Let us now test the image generation to confirm that everything is working. Imagine duck in a tree. And there you have it. The image generation is done. If you found this video useful, consider subscribing, and I'll see you in the next one.